Right. So let's go into this problem and all the others for the next 12, 13 minutes, whatever. Just saying you're no different than what we did the last couple days, right? So our mission is to pick a variable and assassinate it, right? So I'll leave it up to you. I know how I did it, but I don't, that doesn't matter. So like, which variable would you be inclined to want to get rid of? Y's are fine. So let's get rid of the Y's. And you could have said X's or Z's, and it's all good. So that's what's nice about how we solve these nowadays is that um, did I just lose something? I think I might have lost something. Yeah, hold on a second. I gotta pause the video. I so you want to get rid of the Y's. So how are we going to make that happen? Perfect. Good. And the signs are already set odd man out, right? We got a positive, negative, negative, so we're good. So we're going to go times 3, times 2, and times 2. What we're looking for is an irregularity. You can always, the ones you've been doing, the 16 of them that you've done or are working on for me so far, they all just are unique crossing points, right? There are no irregularities. There are some little shortcuts that happen periodically, but we still find a point a point that is the unique solution. This one, you'll sniff it out. You'll know. So let's just do business as usual. We multiply the top by 3, and we get 6x plus 6y minus 6z equals 36. And then the second equation will be negative 8x's minus 6y's plus 2z's is equal to negative 18. And then the third one's going to be negative 6x minus 6y plus 6z equals, what is that, negative 36. So I came into this deciding how I wanted to say this. If you're like mathematically clever, or not, maybe that's not the right word, like confident, if you don't look at math as just a scary thing, but as just a puzzle, then you could already make an observation. And I would just pose this to you and you answer or don't. Is there anything up there that you see that is worthy of note? Which ones? Correct. And so if we identify, and you don't have to spot it now, because it will happen eventually, like the irregularity is going to show itself at any point. How early we spot it, though, is really the key. So what we're going to see here is, and if you just eyeball it, you could actually stop right now and say infinite solutions. And I'll show you why that is. So one of the row combinations that we're going to do, like, this isn't anything new for today, is we would do row 1 plus row 2, right? And if that's the first one that you do, then okay, that's fine. And I would not have done this one first. Like knowing what I know about this process, I would have done what Irene said. I would have just beelined straight to the row 1 and row 3. But let's just say, you're kind of listening to your music, maybe chatting with your friends, and it's just another problem. So if we add row 1 and row 2, we get negative 2x's. We get the y's to cancel. We get negative 4z's, and 36 and negative 18 make 18. And we're just like, whatever, send another text or whatever. And we go on to the next one. But this is the one that if you spotted it early, you could have done first. And that's row 1 and row 3. And, you shouldn't be lost because we're doing what we've been doing the last couple of days. We're making the y's eliminate, right? So if you add row 1 and row 3, you get an elimination on the x's, accidental, or whatever you want to call that, it just happened. And then the y's were the ones that we did on purpose, and they also cancel. And then the z's, again, accidentally, by happenstance, also cancel. And we're left with a void. And in math, a void needs to be represented by the number 0. Okay. Usually when things eliminate, I tell you don't put anything. right? Zeros just get in the way. But if you don't put anything on an entire side of an equal sign, then the equation has no meaning or substance. So that's a placeholder zero that usually we leave out. In this case, we need it. So we're going to say zero equals. And then on the right-hand side, when we add our constants, the 36 and the negative 36, what do we get? We do. And that's the irregularity that I'm talking about. And we saw this in Algebra 1 with systems, that when we solve systems and the variables all eliminate, we know immediately that we have to leave the land of regular thinking and go into our logical thinking. And we're always going to find ourselves in one of two positions. When we have a number, an equal sign, and a number, there are two things that can happen. Either what you see is true or what you see is a lie. There is no wiggle room. There are no more variables in the problem sitting in front of us for us to manipulate. We ask ourselves, does zero equal zero? Will zero always equal zero? Is more to the point, and the answer is yes. For that reason, what we just figured out is that this top plane and this bottom plane are actually the same plane. And as you saw in that video, that means that they sit right on top of each other. Do you understand that? And we can see now that the third plane is tilted differently. The third plane does not match up with them. He does not have parallel characteristics. For him to have parallel characteristics, and we would have spotted this already based on how we did this, but we would see numbers that pair also again with the sixes, and we don't. We see an 8, a 6, and a 2. So for that reason, that third plane is tilted differently, right? And so we can say right away that there are going to be infinitely many solutions because those two planes sit on top of each other and the third plane is not parallel to them. There's zero chance I could draw for you what I want to right now, but I did find a tool that will allow me to show you in a little bit. Desmos just released a beta version of a 3D grapher, and it just about gave me goosebumps when I found it. I've never seen anything maybe that cool before. So we do now have a 3D thing that graphs planes, and it's wonderful. You may not be as geeked about it as I am, but it is wonderful. So I'll try to show you that in a little bit. But anyways, that's what it looks like when there's infinitely many solutions. You probably already know where this is headed because you saw the answers if you were looking, but let's head to number 2. Like we're done with problem 1. You don't need to finish. Once you figure out that there's two planes sitting on top of each other and the third plane is not parallel to them, you're done. Infinite solutions. So the way you would write your answer to this is you would say infinitely many solutions. You may not write all real numbers. That is not true. When we say all real numbers, that's a lie. That means that every point in space would solve the system. To say that there are infinitely many solutions and to say that there's all real numbers are completely different statements. So don't make the mistake of trying to say like all numbers, because that's a lie. There are infinitely many, but it's not all of them. Okay, let's take a look at problem 2. Who are we going to attack in problem 2? Sure. That's an excellent choice. Sorry. That's my bad. I feel bad about that. So if we do the x's, what's great about this is we can just multiply one of the equations and leave the others alone. So the only one that we need to switch is the middle, because if we turn him into a -4, then he'll pair nicely with the positive fours above and below him. So I'm going to take a moment, as annoying as it is, and I don't really care if you like this step or not. I'm not asking for your approval. You need to copy things down. It is part of the deal. So that's not going to be something that I leave up to you. So annoyingly, we're going to copy the first equation and we're going to copy the third equation down because we're not changing them. And then we're going to take our new modified second equation and stick it in the center. So we're going to get -4x's. We're going to get +4y's. We're going to get -6z's. And that's going to be equal to +16. And I would ask you again at this point to just observe, right? Don't panic or think like, oh, it's math. It's got to be really hard. Just observe. Do either of the equations stand out to you? Correct. And what about them stands out to you? X, Y, and Z all cancel out. And what that means is that those planes at the very least are parallel to each other. I'm going to say that again. It means that at the very least, they're parallel to each other. Like in the last example, they were more than parallel to each other. They were sitting right the heck on top of each other. But in this case, they are quite literally going to be parallel to each other. Do you know why they're parallel but not the same?
Zero doesn't equal zero.
Good for you. Because this time, when we add row two and row three, and listen, this time I'm not going to waste my time with row one plus row two. I'm not interested. I'm really interested, and I hope you are too, in this combination right here. These two rows are where we're going to get to our answer quickly. By adding those two rows together, I observe that the x's eliminate, the y's eliminate, and the z's eliminate, leading me again to having to say zero equals. So I'm in a waiting pattern now, and I simply have to ask myself, am I going to get a zero equals zero, i.e. they're the same plane, or am I going to get a zero equals something not named zero? And if I get zero equals something not named zero, like in this case, 16 and 4 are sure as heck not zero, right? They're 20. And zero, no matter how hard you try till the end of time, is never going to equal the number 20. Therefore, those planes are parallel. And like we saw in the video, if the planes are parallel, it doesn't matter anymore what the third plane now does. I mean, I shouldn't say it like that. Yeah, I guess I should say it like that. It doesn't matter what the third plane does. I can say that because if the two are parallel, then there's no way to be on each of those planes at the same time. So that top plane can come in and slice and dice however he wants to. But if we've established that the bottom two are parallel, then enough said, right? So what would we say for a solution to this system? There is no solution. Now, might there be places where two of the three planes cross? Yes, that top plane is going to come in and interact with each of the others in turn. Okay, so there will be crossing points, but just no points where all three cross. It's literally impossible if two of them are parallel to each other. So you're going to start seeing problems like this mixed into the concoction, if you will. The next assignment that I give you, which won't be today, it'll be Monday, but the next one that I give you will have a blend. And you'll have what you've been working on, the ones where you solve them and you get like X is 4 and Y is -2 and Z is 5 or something like that. Like, okay. And then you're going to start seeing these mixed in. And they won't be like in order. They'll be whenever they want to occur. Do you understand how to spot the weird ones? Do you see where it comes from? And this is my last question before I cut myself out. Do you understand, and this is really important that you don't just say yes, so I'll shut up. Answer honestly. Do you see why that top plane is assuredly not parallel or matching the other two? Do you see it? Do you see how the 4 and the 5 and the 3 do not proportionally match up to the 4 and the 4 and the 6? You buy that, right? That's why it has to be tilted in a different way, meaning it has to cross. And that's not as important in this problem because we've already established that if the bottom two are parallel, who really cares about the top one? But that thinking is mongo important in the first problem. Because remember, if the top and bottom planes match, we still run the risk that the third plane, the one in the middle that I just circled in purple, could be parallel, right? And if two planes are on each other and one is parallel, we could get a false reading if we say infinite solutions. Because if that third one's parallel, then I'm like, oh crap, I forgot to consider that. Third guy could ruin everything. But again, look at the proportions of the numbers. I said this 8 minutes ago. 8, -8, -6, and 2 are not proportionally matchable with 6, 6, and 6, right? Therefore, the plane has to be tippy-doed in some way, meaning he's going to touch the other planes. Do you got it? Okay, good. Mission accomplished. So I'm not going to go through the other two with you because the clock says I can't, and I don't really think I need to anyway. So that's today. Please, when you show up Monday, have assignments. What were they? Have those done, please. And the answers for both assignments, I believe, are on Canvas already. So you should be able to say, I'm done. I've graded them. I'm ready. And then we'll start doing row reduction on Tuesday. And that's where all the letters are going to go away. And we're just going to use ones and zeros. Yeah, you won't love it, but it's not that bad. Got it? No questions? Sweet.